When you decide to overuse your cameras, lights, and door controls in Five Nights at Freddy's, you're left to sit in darkness. But the end doesn't come quickly. Instead, you're forced to sit there and listen to the fans and generator slowly grind to a halt. Eventually, you'll begin to hear footsteps from far away, slowly getting closer, until finally, you think they're right outside your door. Surprisingly, carnival music begins to play, and an animatronic lights up to your left. It's strange, but for a moment you think everything might be okay. But then, as abruptly as the music began, it cuts out, before absolute darkness envelops you. And then, the footsteps begin again, this time coming even closer. You know that thing is in the room with you, and it just waits. Until finally... And that's when the game really ends. In this video, we're going to create the Power Manager system, and it's going to be used in subsequent videos to allow us to draw energy from our limited pool of resources. We're also going to create the entire end sequence I just described, including the long wait, the animatronic footsteps, the light up action at the end with some music, and then finally, a jump scare. As always, the scripts that I provide are available on my website at gleecakes.com. And for those of you who are a creative tier member of my Patreon site, you get access to all of the assets you're going to see here, so you can follow along with the project. Section 1, User Interface, Scripts, and Flow. Let's take a moment and map out the different elements we're going to need to create to have a power system inside of our version of Five Nights at Freddy's. The first section we're going to cover are the user interface elements. Here's a quick diagram showing the different parts. We're going to start with a panel called Power Usage. Within that panel, we're going to contain all the different graphical and text elements we need to show the player what's going on with the power. We have text that just says power left, and a value that's going to update as we slowly lose power. We then have a power usage text field that's going to use a series of 5 different images to indicate how much power we're drawing down at any particular time. In this video, we're not going to integrate in the different systems into the power draw. We're just going to crank up the power draw to be obnoxiously high so we don't have to wait 5 minutes for the entire thing to die out. As we add more items that draw power, we're going to indicate that by increasing the number of bars visible on the screen. They'll start green, go yellow, and then finally end with red color. Five Nights at Freddy's doesn't originally have as many bars as I'm putting here. I'm adding it to show you can add as many of these as you'd like. We will have to go back and update several scripts from the past in order to make use of the Power Manager and also disable different parts of it as the power gets shut down. When we've completely run out of power, different parts of the user interface need to be disabled or completely go invisible. And if you have the map open, it needs to close in front of you. So all of that has to be integrated into our new Power Manager system. The first script we're going to talk about is the Power Manager script. The Power Manager features 3 events that will allow other systems to subscribe to it so they can be notified about when the power goes out, when the power value has changed, or when the usage value has changed. Power Manager has 2 methods that allow different systems to either add a power sink or remove a power sink from the system. These are called Add Draw and Remove Draw. Not exactly the best names, I'll probably change that later on. We also have a method called Get Usage that informs how much of the system is currently being used. Finally, we have a reset value. And reset is very important now because whenever the night resets, we need to make sure all the different components also reset along with it. The next script is Power UI. Power UI is going to control all the graphical user interface elements. Specifically, it's going to have about 5 methods that are very important. The first 2 are for updating the usage UI and updating the power UI. We then have methods that hook into the Power Manager for on power changed, on usage changed, and on power out. Finally, we have the Blackout controller. This is going to handle the entire animated sequence when the music plays and the face shows up and starts scaring you. We have the on power out method, which gets called when the power goes out, This is going to start the entire sequence off, including playing the footsteps, the music, the flickering face, and then finally it will trigger a game over. It's the coroutine blackout sequence that's actually going to handle all of that stuff. Then we have the method random flicker face, which is going to be in charge of randomizing the flickering of the animatronic's face to go from no animatronic being visible to different intensities of flickering. Now let's discuss the end sequence flow. I always find it's easy to map this out so I know exactly what I'm programming, especially in complicated scenes. We're going to start with the room going very dark, but not completely pitch black. Instead, we're going to add like a slight blue tint to the scene. The doors are then going to open, which we haven't implemented yet. There's going to be a low-pitched whine that plays for roughly 15 seconds, and that represents the power going out and maybe this power system shutting down. Then we're going to begin hearing the footstep sounds getting closer and closer. Next up, the carnival music begins to play. Now, I didn't have any carnival music or any free and open source music to use, so I ended up creating my own. It's not exactly carnival music, but it sort of works. I'll probably go back and change it later on when I have more time. While the carnival music plays, we get that face to flicker back and forth. Once that's all over, we go from that dark blue to a completely pitched black image. We then hear the footsteps again, getting closer and closer to the player, with a small pause, and then finally we trigger a jump scare. Preparing the visual assets. In the first video, I used a rendering from Unity to represent the control room, and I considered going back into Maya and recreating the entire room with Arnold level rendering and great lighting, but I decided not to do that, because it would probably take a few weeks to set everything up and get it ready for this video. So in the interest of time, I've decided to manipulate the original image I provided inside of Photoshop. Here you can see the original security room texture that I've been using this entire time. I then took that layer, duplicated it, and then inverted it. And then I used the linear burn effect on that layer. This darkened a lot of different elements, especially toning down some of the brighter parts that are a little bit too overblown. I wasn't completely happy with how that looked, so I decided to just colorize the entire layer. I then put a gradient over top of that to see if I could darken the edges while keeping the center a little bit brighter. I then highlighted the brightest parts of the image, the white parts, making a new layer and overlaying that on top of everything else. This caused the brighter parts to be much dimmer, so they didn't pop out as much. I then created masks for the doors. I don't want to be able to see into the hallways, so I just filled them in with black. I then played with a few different layers. Here you can see some exposure and hue and saturation values. If I turn these layers on, you can see they tone down some of the blue and make it a little bit more aqua colored. Because I don't have a version of the animatronic head in the current version of my Unity project, I actually needed to go back into Maya, but I didn't want to create the entire room because, as I mentioned, that would take weeks. So instead, I isolated the pug head by itself in a new scene and then used the Arnold renderer to create renders of that face from kind of a forward-looking direction. If I go to the Arnold renderer here, you can see the different materials and light source that I put inside the scene. This is the updated pug model. I actually haven't shown or released this yet. These assets are meant to be used later on when we get to the animatronic sections of this video series. I ended up creating several different renders of my pug inside of Maya, and then I brought them into Photoshop, but I did have to do some manipulation to get everything to work. Here's my pug layer, and inside of that you'll see the different faces. I have some mild versions, some various ones with different intensities. In order to get some of the lighting around the area that should be illuminating the door frame, I also took the pug face at its brightest intensity and just blurred the heck out of it, so the surrounding area seemed to have a little bit of a halo as it lit up. Here you can see that effect right there with the door. Now the noise was a little bit of a problem because my image is actually squashed on the horizontal axis. So to make this work, I filled the entire image with noise and then I squished it by half, moved it over to the left, duplicated that layer, and then moved it over to the right. This way the proportions on the noise look a little bit better. Finally, I added another levels on top of everything else, which dimmed the entire room to that pitch black feel you get after the animatronic head disappears. Creating the Power Manager scene. In order to isolate all the development of this video from the rest of everything we've done, I created a new scene. This one's called test_power manager. Inside of this, it's going to hold a canvas, and within that canvas is eventually going to be the prefab we're going to drag and drop from our inspector into our project window. Here we can see the canvas power manager and then the prefab already completed. We start with a panel that's going to fill our entire canvas, and all the different UI elements are going to be structured underneath of it. The panel itself holds the power manager, the power UI script, and the Blackout controller. You'll notice that each of these scripts has a reference to the other scripts. You could have written these scripts so that it would have found the object automatically if it was attached, but you might want to change where these scripts end up being and put them on other game objects. So I left the references open for you to drag and drop later. Under the panel Power Usage, we have another panel called Power Usage. Once again, I should probably change that name later, but this is the one that's going to hold all the usage information. We have a text for Power Left, a text object for the Power Left number, which will be updated via our script. Then we have the text Power Usage over on the left, and then we have the various bars. These bars are going to be added slowly over time as more objects use power in our system. The bars are actually just black and white objects. I use the color property of the image component on that game object to modify them to make them either green, yellow, or red. In case you're interested, this is the actual Photoshop file I created for those power bars. I kept it low resolution on purpose to kind of keep the same feel as the game. This image is actually only 16 by 16 pixels. You can see that the left side of the image is a white element. This is so that we can colorize it in our game object using the image color component. The other game objects we have under our panel power usage are the audio sources. We have an audio source for the breaker, which is when the lights actually go out or the doors close. Then we have the long walk audio source. This is the sound of the animatronic slowly moving towards you. Then we have the generator winding down. Next we have the power outage music, which should be that carnival music, but once again I don't have carnival music, so I just made something that's kind of different. Finally, we have the last 3 steps before the jump scare actually occurs. Once we've created all the scripts and gotten all that stuff wired up, you'll eventually take this prefab and then drag and drop it into your main scene. I'm showing this to you now so you know where the prefab's going to end up. Here is our main scene where we have our canvas for our entire background. I drag and drop the prefab into my canvas_background game object. You can see it right here. And here are all the different components that make up that object we just covered. Now let's take a high-level look at all the various scripts we're going to be creating and attaching to our game objects to make the Power Manager function. Let's start with the Power Manager. We have a starting value, which is how much power it has. We're going to start with 100 so we can do simple percentages. We have a base drain rate. This is how quickly power is going to be drained from the system over time, even when nothing is on. We have a dictionary of different active rates. These are all the various objects that are going to be draining power from us. We keep a list of them, and then we can add or subtract them over time. We have a value called isRunning, because sometimes the Power Manager is going to be off, especially when the power goes out. Then we have a flag for when power outage has been raised. This allows the system to know that, hey, the power's out, it can't go out again. Importantly, we have 3 different actions. Those are on power out, on power changed, and on usage changed. Now this could get fired a lot, so I actually limit it to only change when the integer value changes. The idea is that maybe there are other systems in our game eventually that might want to become more difficult as the power gets lower and lower. Or maybe we want certain animatronics to only come out when the power has reached a particular threshold. There's a lot of ways you can use this creatively to have some fun mechanics in your game. In our awake method, we go ahead and set our current power and the current power integer using a clamp function and a round to integer value. This way, in case our starting value ends up being something weird, it still is between 0 and 100. In start, we go ahead and invoke our on power changed and our on usage changed. This allows all the different UI elements to properly update when the game begins. In update, we check to see whether or not we're running and whether or not the power outage has actually been raised. Obviously, we don't need to update any of the power systems if everything is shut down. Here we go ahead and calculate how much power we need to draw every frame. We begin with the base power drain, and then we iterate over every single object in our dictionary and grab those rates and add them to our power draw rate. We always make sure that we don't allow this value to go below 0 so that our menus don't update with a negative value, which wouldn't look good to the player. We also make a call to check power int change, which we'll explain in just a moment. We then check to see whether or not our power has gone to 0 or below. And if it has, we invoke our on power out, so all the other components that have subscribed to us are notified about this event occurring. Add draw is very simple. It takes in an ID that's a string as well as how much power to draw per second, and it adds it to our dictionary. It also invokes the onUsageChanged event, so anyone subscribing to this will know that our usage total has changed. GetUsage calculates how much usage is currently going on. It's pretty much just the number of objects that are using the system. If the system is running, its usage is always 1. You're always having some kind of amount of power draw. Remove draw goes through our dictionary, checks to make sure that there's an ID associated with the one we've passed in, and if there is, it removes it from the dictionary. And then it lets everyone know that, hey, the power usage has changed again. Check power int changed does all the work of taking that floating point number and making sure it's the right integer value. We go ahead and invoke the onPowerChanged event. Again, this is so we don't have this small floating point number flooding us with events every single frame. Lastly, we have the reset method, which is very important to make sure the game functions every time the player loses. We go ahead and clear everything, reset our values, and also invoke an onPowerChanged and onPowerOut. Now let's take a look at the Power UI script. The Power UI script has references to the Power UI panel, the Power Manager itself, the remaining power text, as well as the usage bars, which is an array of image objects. OnEnabled and OnDisabled are going to subscribe or unsubscribe from our Power Manage events, the onPowerChanged, onUsageChanged, and onPowerOut. Our Update Usage UI is going to iterate over our bars and enable or disable those. I have 5 bars, so I can have usage up to 5. Update Power UI just changes the text. OnPowerChange and onUsageChanged, whenever those values change, they update the user interface as well. Let's now talk about the Blackout controller. This is going to be the heavy lifter for all the animated sequences that happen when the entire power system fails and all the lights go out. We have a lot of references in the script. We're going to need the Camera Manager, the Jump Scare Sequence Manager, and the Power Manager as well. Now we have the different textures I made in Photoshop for the different states of the room. First we have the normal room, the no power one, which is that darker but kind of blue tinted room. Then we have Anim 1 and Anim 2. These are the animatronic lit up at different intensities. Then finally, we have the entire blackout scene, which I have misspelled to be backout. You can rename that properly. The last set of references are the audio references. We have the breaker switch, the animatronic long walk, the generator slow die, the power outage music, and the last 3 steps. I showed you all those audio sources in the project already. Our start method is going to make sure we subscribe to the Power Manager's onPowerOut event so that when it goes out, we can make this entire sequence occur. When the power goes out, we start a coroutine called C_blackout sequence. C blackout sequence is a long function because it is stipulating everything that happens in that flow sequence we talked about before. We're going to do a yield return null just to make sure that this gets an extra frame to fire off in case we're waiting on anything else to happen. We're going to swap that texture to dark blue, and we're going to play the breaker sound effect, which might be replaced by the doors closing later on once we have that implemented. Next up, I play the generator slow die. I then calculate the difference between the slow dying generator sound effect, which takes a while, and the animatronic long walk. I know the long walk is shorter than the animatronic slow die down. I get this delta difference to know how long to wait to give me a little bit of a pause before starting the footsteps. I then wait for that pause time. I then play the long walk sequence. Once that's finished, I know the walk is done, and I play the carnival music. Next up, I have a start coroutine within this coroutine called random face flicker. The idea here is that I want the face to flicker on the screen. The problem is that the flickering needs to end before the audio clip ends. The reason is because I had this fall off at the end of my audio clip, and I don't want the face to be continuing to flicker while that fall off is occurring. We then wait for a small duration afterwards to kind of make the player feel some pressure. And then we go ahead and play that breaker switch sound again when we go from the dark blue background to a completely pitch black background. Finally, we wait a little bit longer before we decide to play the footsteps just to build some anticipation, and then we call the jumpscare.play method to kill off the player. Random face flicker is a pretty simple method. It takes in a length and then takes in our texture array of different textures to swap in and out. The first element in the texture array is the no power element, followed by the 2 ones with the animatronic. And I pretty much just go through and I see, should we even swap the face? Maybe we want to hold on the face, so I give it this 50-50 chance on either holding on the face if there's a dark room or changing the face if there isn't. Then I take some random values that are very short, like 0.0 or 0.2 seconds, and I wait that amount of time. I then decide which of the two different images I should swap between by calling another random.range. And then I set the backroom's texture equal to whatever texture I decided to pull randomly from that array. You could create a lot more textures than the two I have here. It's entirely up to you. Finally, I call the camera manager.set room background to the original dark blue background before I'm done with the sequence. Updating the map animator. If you happen to be in the map menu when a power outage occurs, we need to close that menu and actually shut down all the user interface elements. So we need to go back and update the map animator script to make this work. Here you can see the map animator script. Now I didn't add a reference directly to this. Instead, within the start method, I decided to go ahead and grab the first object we can find that's a power manager. I only plan on having one power manager per scene, so this is a fine method of finding the only one that's available. I then go ahead and subscribe to the power manager on power out event. Now when the power goes out, the on power out method within map animator gets called. Inside of that, we call the hide map method, which gets rid of the map from the screen for us. But then we also need to disable the button that controls the ability to go over and open the map up or close it. For right now, I just simply make a call to the map button image.gameObject.setActive and make it false. Within my scene, I also went around and kind of tweaked things. So if you want to take a few moments, pause the video and see what my scene layout looks like, notice particularly the canvas background and the layering of these different objects. And with that, we've completed everything we need for this system to work. I went ahead, went to File, Build Settings. I made sure that I added this scene to my build, and I built the whole project out. Let's go ahead and take a look at what happens when we play the game. Now, if you want to know how I created some of those different sound effects at the end, I went into my garage, I grabbed the biggest tool I could find, which was a very large pipe wrench, and I just dragged it across the floor with my cell phone recording the sound. Took it into Adobe Audition, and I played with the pitch and as well as the duration of the sound effect to draw it out to make it sound like it was a larger animatronic coming through than my tiny little pipe wrench was doing. For the end music, I used the Magix Music Maker 2015. You can see that right here. I created the first pass here, and then what I ended up doing later on was I took the whole thing into Adobe Audition and I played with a lot of different parts of this thing. I stretched it, I changed the pitch, I made some parts slow down, other parts speed up to give it kind of a creepy element. And that's it. In this video, we've created the entire power management system and we're ready to integrate it into other elements that we're going to be adding later on in this series. Why don't we take a look and see where exactly we are on the roadmap right now. I had to update my roadmap a little bit because I covered more topics in this video than I expected. Now we're done with the power manager as well as the outage sequence. Next up, we've got the Pug AI and the Foxy AI. It's going to take a little bit to create because I've got to make all those assets. If you watched my original 3D series, you know that I only have a few of those rooms actually complete. So I need to finish out those final few rooms, enough so that we can have our animatronic go from the front of the stage all the way to the security room and have all those different images update appropriately. Once we get the animatronics done, we're going to look at the player defenses, the story ending, and finally, our finished game. I want to thank all of you out there who are still watching. I hope this series is helping you understand how to create these games and break them down into manageable pieces. I want to thank all my Patreon members out there. Your support continues to help push me every week to create this content and get it done in a reasonable amount of time. And I'll see you all next time when we cover the Pug animatronic, which is my personal replacement for the Freddy animatronic in the Five Nights at Freddy's series. So long and goodbye.